Yeah. Yeah. So good morning. So yeah, it seems now like most of you have registered the course. So I can see that in the role list, it went up to 160, close to, and still I think still some more students are yet to register. Maybe very few, maybe number, maybe less than 5%. And at the same time, there are requests from the ERP also. That number is also a bit large. It's about 95. And so I have not approved anybody because thinking that because incrementally approving, instead actually I want to do it just waiting for today's class, and then after that maybe in the afternoon sometime I will approve the pending. I will approve the request through ERP and all, and so we'll do that. And as I mentioned that yeah, all of you should aware that this particular course yeah, requires the prerequisite of digital electronics offered by either EC department or this one, or switching circuits offered by computer science department. Unless if you don't have that course and all, it is difficult to follow because there are lots of concepts or topics that were based on that. So while dealing with the topics and all, we'll assume that you have that knowledge of that basic background related to that switching and digital electronics and all. So that will be easier for me to continue. Otherwise, for everything just explaining from the scratch and all, it takes a lot of time. It's not possible in this particular framework of this course. So please take care of that. And so those who didn't have that background and all, so please kindly withdraw. And today afternoon, maybe around after 12 o'clock, maybe afternoon, I will approve. Don't worry, because I'm getting a lot of mails from the individuals, so I didn't answer to anybody. The reason is that, as I already mentioned, that it's simply not possible for responding to all your individual emails and all. So as far as possible, we'll try to clarify or answer the queries during the class at the beginning and the later part and all. So that's the reason I have not done. Don't worry. So today afternoon I will I will approve all your requests and all. So before that, you please voluntarily you yourself withdraw if you don't satisfy the constraints and all. Don't worry. And another thing is that actually by today I may approve till today and all. Afterwards, there is any further request, I may not approve because already the class size is growing. So it's crossing 200, 220, 230 and all. So therefore, there will be other withdrawals will be there later on. But anyway, however, so I will see that by till today evening, night, I will whatever the requests were there, I will try to approve. But after that, I may not approve because if you at all, if there is any interest, if you want to do it by this time, you people might have registered and all. So most of you have done that one. So therefore, there won't be any problem that keeping a deadline of today evening so that I can do that. I will do the approval, and later on I may not. I will not go for approving any further requests beyond 5th, 6th. Today is 6th, right? So this is one thing regarding the class, the approving the approval regarding the course requests and all that. I will do that. And another thing I come to know that yesterday somebody has raised that the number of class tests and other things, but I don't know, this thing has changed recently. But I'm not aware of that because even the last year, as I mentioned, that myself and Professor Mal both have conducted the tests weekly, and it was felt that the students also felt enjoyed because almost every week we used to conduct the test without any final test. So that way, it's just their students also, like you also have to just prepare for those 2 lectures for the next test and all. The test will be like kind of like as I mentioned, 15 minutes, 20 minutes test. That is the way we happened. But some of you have raised that, and then later I get it clarified that yeah, as you mentioned, because that constant that the tests, the test week and other things that was last time it was mentioned for the first years, so we followed that for the first years. So now it was, I think, meant for across all the years. Seems to be it's like made it like uniform across the entire thing institute. So then okay, fine. If that is the case, then we'll go ahead with that itself. It means we'll have only two tests. One is during the mid sem, that is during the middle of the week, middle of the semester, that like in February sometime, around 17th to sometime. It's there in academic calendar. We will follow that. And at the end, anyway, April 7th or April 10th, around that time. So we'll follow that. We'll have only two tests, and both the tests will be like a conventional test, pen and paper test and all. And so we'll see that most probably that way, like the first test will be covers the computer architecture part, and maybe the second test may cover the operating systems and all. Okay, so that way we'll have the evaluation, and both of them have the 50%, 50%. So that way you have only two tests to do that. But I feel that sincerely feel that it will be hectic for you because yeah, hectic means yeah, it's not hectic in the normal sense, because anyway you do in the conventional exams, you prepare for the whole syllabus for the end sem and all. So the same way here also you have to do that. But since it is online, last time we felt that myself and my Professor Mal felt that it may be easier for you. That is the reason we kept. But anyway, at that time we have a freedom. We have told that it's up to the faculty. You can keep the test. You can make the evaluation process as well. Anyway, okay. So I hope it's clear to you, all of you, that the evaluation will be like in the last class I mentioned that evaluation will be based on two tests plus the class test that will be there in the every week mostly. That's what I mentioned. But now it is supersedes that whatever I'm saying now. Like you have only two tests. That is one in the middle of the semester as per the academic calendar, and the second one will be at the end. Okay, and the syllabus also I'm just saying now for the like for the middle test, for the midsem test, the syllabus, whatever we cover till the midsem, it will be there in the midsem test. And for the end sem, whatever we cover after the midsem until end sem, so that will be as a part of your syllabus for the end sem. And strictly speaking, the end sem should contain the whole syllabus and all, but for the sake of like simplicity and to avoid the you were saying stress and all, but so for that, I'm just keeping the part. I'm just partitioning the syllabus itself two halves, and then we'll keep the test independently, right? And another thing, yeah, I agree that there are constraints now and all. Basically, this online mode, keep on listening to the video lectures and all. It's different from the conventional framework. I understand, but you just put your effort, whatever you can. Don't stretch beyond the limits and all, so that you don't be stressed, right? That's what I want to convey that. And I hope the things are clear now, both the evaluation strategy and the approval policy and all. So we'll go by that. Okay. And so now without any further delay, let us start the class where we stopped. And I'm just sharing the slides. Yeah, today I will I will upload the slides in the module in this Teams. Yeah, right. And anyway, the recordings will be automatically they are placing the recordings in the files. So you can see that already it was there, the previous recording, yesterday's recording. Okay, yeah. So, yeah, is this slide visible? Hello? Hello?
Yes, sir. Yes, sir.
Yeah. So can I go ahead? So, any questions regarding the last class lecture? Yeah, okay. So, yeah, yesterday we are discussing about this, the performance of a computer and all. And as we mentioned that the performance that depends on the class of systems and all. like whether it is the personal computer, then the performance will be kind of the response time. And whereas in case of server and all, so usually the performance will be measured or performance will be appreciated if you can analyze the throughput instead of the response time of the individual tasks and all. And and so far we just discussed about just a brief view of different classes of computers, that part. And then we just mentioned about what is there. So because for carrying out the applications, we write the application program. So below that program, what are the various things were there, and similarly in the hardware and all. And we, as you mentioned in the last class, we are just discussing about what are the various factors that are affecting the or various aspects that are affecting the performance of the program and all. So we mentioned about these are the four things that are affect the performance at algorithmic level, where the performance depends upon algorithm. That means if we for doing the same task, if you choose a better algorithm, the number of operations will be reduced. This is, you just try to visualize that. For example, just simple, very known task kind of. Suppose you want to sort the array kind of a thing, sort the numbers, for example. We have different strategies are there. So if you use a particular algorithm where the number of operations will be like order of n square, and if you use some other strategy, some other algorithm method, where the number of operations can be reduced to like n log n kind of a thing. So likewise, by choosing appropriate algorithm, the number of operations depends on that. And then afterwards, using the programming language, then that is algorithm is at a very higher level, close to the our human thought process and all. Then after that, you have a programming language, compiler, and architecture. And these are the ones where they used to translate that algorithm in the form of instructions, very basic instructions, or which are understandable by the basic the hardware and all. So for that, these are the various other layers of software that used to be there. Programming language is known to be high-level language, then a compiler, and then the architecture. Here, architecture is nothing but the set of instructions that are supported by the basic hardware and all, right? So, and here the compiler's job is that the high-level language, the algorithm, whatever is coded in the high-level language, so it will be transformed to the basic instructions, which are understandable by the computer or the basic hardware and all. So that will be carried out by the compiler and all. So again, a compiler is again a software, a piece of code. So where it will take the input as each command of the high-level language, and it will be transformed to the instruction which is understandable by the hardware and all. It's not single instruction. Sometimes if you take a single command, so that itself will be realized as 3 or 4 basic instructions which are need to be carried out to perform the single command in the high-level language and all. So anyway, we'll see those details later in the next chapter when you are dealing with the machine language and other aspects and all. So these things also will determine the number of basic machine instructions executed per operation and all. Like here, the algorithm will basically define the operations at a gross level, and then each operation will be again coded by using high-level language, and followed by compiler which used for translation and all. And the architecture provide the set of or a finite set of instructions and all. So all these three also will influence the number of machine instructions that are executed that are required for a basic operation. And then anyway, these are the hardware things like processor and memory. So that determines how fast we can able to execute the instructions using a processor and a memory, by using high-end processors or by using the effective or using a memory which is a faster memory, and also where you can able to access the data from the memory and all in very faster manner. And similarly, the processor, the nature of a processor, based on that also, it determines the how fast. That means what is the execution time of each individual instruction and all. So that finally determines the performance of the system and all for a given program. And likewise, the I/O systems also, like input output systems and all, because when you're executing a program and all, you need to provide the input at a different instance of time and all, that depending upon the application sometimes. And at the same time, you also display the output also at some intermediate points. So based on the output, the user can change the input. So in these occasions also, the program execution time depends upon how fast the IO system will be, like how fast this IO interface responds to the responses as the program is execution. So these are the four different the events where they can contribute for the performance, at a very gross level. Okay. And so this is just an example where to just suppose if we take an example of matrix multiplication. So by providing the different optimizations, you can able to see that by using the data level parallelism, you can able to achieve roughly about 4 times the faster. And by using instruction level parallelism, you can able to achieve around 2 times or slightly more than 2 times. And by using the memory optimization, using the memory hierarchy optimization, like by using a different memories at different levels, like a cache memory, main memory, and the other secondary memory and all. And so with that, you can able to achieve performance, the enhanced performance about 2.5 times. And by using a thread level parallelism, that means while writing the program, if you can able to introduce the concept of threads in the programming, and if you have a sufficient hardware having a multi-core architectures and all, then by incorporating a thread level parallelism, you can able to achieve the speed of about 14 times. So altogether, you can able to see that the overall speed up will be 200 times you can able to achieve. And these things, the details of these things, the data level parallelism, instruction level parallel, these things and all we can will come across as we are going to the later chapters and all. Like for example, in case of data level parallelism, suppose we want to perform for example, 32-bit multiplication, for example. So that in case here, instead of performing 32-bit multiplication directly, you can able to split that word into the different bytes, 4 bytes, and you can able to perform the multiplication parallelly. And with that, you can able to achieve certain improvement, certain speed and all. Likewise, the instruction level parallelism also. Like this is nothing but when you are executing instruction, it's not that instruction is executed. Instruction execution takes at a different events. Like first of all, you have to fetch the instruction, then you need to interpret, decode the instruction. Then afterwards, whatever the operation is supposed to be, that has to be performed. Then that outcome has to be placed in some place in the memory or in some register or something like that. So what I mean to say is that the instruction execution is not a single shot or a single operation. It like have a multiple sequence of operations has to be taken place, and all operations has to be taken in a sequence. It cannot be done in one shot, in one no, in simultaneously or instantly and all. It will be done like in sequence and all. So for doing that, you can use the even it may be a single processor and all, you can use the instruction level parallelism, because as I mentioned that instruction has to be executed in multiple stages and all, in a sequence of stages. So you can able to use the instruction level parallelism. That means you can keep the instruction in a pipeline, like first instruction let us fetch, and then afterwards you can just pass on to the decoding stage. At that time the fetching is free, so therefore you can fetch the next instruction, and after decoding then the previous instruction can be pushed into the registers or memory somewhere, and then you can then this particular stage, decoding stage, is free. So then the previous instruction can be fetched into the can be passed to the decoding. So likewise, assuming that the instruction execution will be a sequence of operations, sub operations, and if you can able to do the compartmentalization of that one, and then you can run, or you can use multiple instructions can be execute parallelly, right? So that is known to be instruction level parallelism, or a process of pipelining and all. We'll see that in the fourth chapter when you're discussing about a processor and all. We have a process which can support the pipelining to achieve a better performance and all. Like memory hierarchy, as I mentioned, that instead of having single memory, where if you have the multiple memories at a different hierarchy, where you can keep the fastest memory very close to the processor or within a processor itself, then in that time the memory accessing time will be very easier, very simple, or very less, very it's very optimal and all. Like otherwise, if you want to access the data from a normal main memory RAM, it takes orders of time. It takes about 50 milliseconds or at that range, 100 milliseconds. Whereas if you keep cache memory, which is faster one, close to the or we are part of a processor and all, then it will be like much faster and all. Like it will be order of nanoseconds. So that way you can able to achieve a better performance. Then the thread level parallelism is nothing but if you write a program as the independent modules, and then you can able to carry out the same program can be run on the multiple processors also by exploiting the thread level parallelism and all. So with that you can achieve better. So this is all these things you can get a clarity as we go on in the later chapters. This is just an example to just say that how the performance is enhanced in the recent past compared to the earlier conventional systems and all. Yeah, the next thing is that this is a kind of like very guidelines, or you can say that the policies that are followed by the computer architects and all when they are designing the computer systems. So these are the 8 the basic policies which were thought of or which are starts they are implementing at the beginning of the computer era. That means in 50s, 60s onwards, they started thinking of these things and they are using. But still, even now also, the recent computer designers also still respect these the basic ideas, which will try to show their still their existence, and they are still indeed they are important, and they realize that by respecting these guidelines when you are designing the computers and all, so it will be useful and all. So these are the like you can see that first one is a Moore's law. Moore's law is nothing but actually from 60s onwards, the researcher Moore, like he's like founder of this Intel. So one of the founders of Intel, actually, he suggested that actually he thought of like for every year or for every 1.5 year, the density of the devices in the within the this on the processor will be increased twice and all. So with that, the computational power will be increased, and also the systems or the process will become economical and cheaper and all. So and this law is holds good till even recently also. Like every year, the packaging density has been doubled and all. So with that, you can have a lot of processing power that is available, and even the memory is also good. The large memories, high speed memories are available with the recent technologies and all. So here the idea here is that if somebody want to design the computer system and all, they should think of, or they should keep it in mind about the Moore's law. That means if they start at this particular point of a time, now the packaging density or the number of transistors in a chip or the chip density will be a certain amount and all. And if they want to design the computers at this point of a time, and they have to think about, because the design will take certain amount of time, maybe year or 2 years or so. So by the end of the design or in future, what will be the growth of the packaging density or the technology? Thinking that you need to you have to go for designing the computers and all. It's not that design the computer for the present for the present features or the present technology and all. You need to think about that the technology will be growing exponentially, and accordingly you have to design the computers which can take care about the future later on down the line, the 2 years or 4 years and so on. And the next one is that abstraction is used to simplify the design and all. Then when you're designing the computer, whatever, whether it may be hardware or software and all, so abstraction is very important. Abstraction means the make the so have a very complex task and try to attack the task, or try to resolve or try to handle the task instead of directly, where you can able to split that task into the multiple subtasks at the different layers, and then you try to attempt each task like independently, and see that all the tasks together, subtasks together, can able to carry out the integrated, the desired goal and all. So that is known to be abstraction. It means that otherwise the things will be very complicated and it will be very difficult to design the complicated task. You can do that, but the problem is that if you, without abstraction, if you can able to do it, if you can able to design or if you can able to develop any system on a monolithic platform without any modules, without any layers and all, later on it will be very difficult. If you want to do any changes in a particular stage or particular device or particular peripheral and all, then the whole thing will be affected and all. Whereas if you can able to like offer the design in a layered fashion, where each layer is designated to do certain tasks, and then the next layer on top of that one, it will not know about the details of the inner layer and all. It just know about what the previous layer will give you the output and all, and what are the output signals, or what is the output from the previous layer and all. Just focus on the output of the previous layer. Based on that, the next layer will be designed. The next layer will just think about some other activity which takes the input from the previous layer, that is the outcome of the previous layer as input to the next layer, and the next layer, the other layer and all, it will do the job, it will do the designated function based on that. So likewise, if you can design if you can perform the like the development in the form of various layers, then the design or the development will be the simplified. And not only that, later on, if you want to do any modifications at any layer and all, you just modify that particular layer, that is good enough, because the internals of the layer is known to the only the designer of that layer. It is not known to the designer of the upper layer or designer of the lower layer and all. So, but it has to ensure that that layer should ensure that it has to give the outputs that are defined, whatever the outputs that are required, the range of output, or like what is output specifications and all, it should follow. And but the internals and all, you can change it sometimes. No, as the technology changes, you can change the internal the devices or the internal whatever the materials, whatever and all. So that's known to be abstraction. This is one example of, for example, when you are writing the code, when you're writing a program, suppose we know that we had to perform certain tasks on a computer and all. So as application level, as a human, he cannot think about the how to write the machine code for this particular application and all. Because as per his thought process, he just design, or he can think about the broader algorithm to solve that particular problem and all, right? So that is at a higher level. And but the machine cannot understand that algorithmic level of solving the problem and all. So machine will work with only a finite set of instructions, as I mentioned, because it just do the very basic operations, as I told you in the last class, like very basic operations like arithmetic operations, input output, accessing the memory, or input output operations, or like logical operations, some very basic operations it will do that. But at algorithmic level, the application is very complicated. It cannot be carried out by a machine. So therefore, you have a different levels of abstraction. So at algorithmic level, at one level where the human will contribute, then from the algorithm, then the human, some professionals can able to code that algorithm in the form of high level language efficiently. And again, from the high level language, there will be another piece of code known to be compiler, where it can able to translate that high level language commands into the instructions, the symbolic instructions known to be assembly language and all. And then again, maybe further assembler can be there to translate this assembly language symbolic instructions into actual binary data. So this is a kind of abstraction where at a software level you can able to see from program to the very machine instructions and all. The same way at a hardware also, you have the abstraction. That means you can't design the processor directly. If you look at the system and all, you have a processor, memory, and so on. The processor, if you look at a higher view, you can have a processor. Then within that, again, you have some subunits will be there, like ALU, registers, controller, and so on. And again, if you further go into the ALU, again, the next level, below level, where you have the adder, subtractor, and the logical units, and so on. And if you go below that, again, the adder, and you can see the gates. So that way, they are finally realized with the transistors and so on. So that way, you have different levels of abstraction will be there to simplify the the design. That is meant by the abstraction, and it's not only limited to this one. Whatever the discussion, whatever we have, this same abstraction can be applicable to anywhere, not only computers, even in the area of mechanical or even in the area of any networking, anywhere, whatever that, if you have a very difficult problem to solve, complex problem to solve, we'll try to simplify that by using the various levels of abstraction, and with that you can able to carry out the uh, any complicated task can be carried out. And the next one here is that with respect to the computer design, we need to ensure that the common case should be faster. So it means that when you are for our in a computer, the common case, that means that whatever the more frequent instructions that need to be executed by the system, that need to be faster, that need to be optimized, and that can be made it as faster, so that it affects the overall performance and all, because those are the instructions, mostly they are the simpler ones, and common ones, they are the very simpler ones, and they are very frequently occurs and all. So therefore, when you are designing the system and all, you need to give a priority, or you have to ensure that the most frequent cases are the most frequent instructions, whatever is there. So they need to be optimized. That means optimized means when you are writing the code also, you should have such instructions should be as many as possible. And while execution also, you need to ensure that you have to design the hardware such that actually those common instructions or the familiar, the frequent instructions has to be done faster, has to be optimized. We need not worry about the rare cases and all, because the rare cases, it may happen, the frequency of that occurrence will be rare and will be less. So therefore, you need not worry about optimizing the rare instructions or the rare cases and all. So we let the rare instruction can take more time. It doesn't, we need not bother about that, because it will not affect the overall performance much. But if you compromise that, if you want to optimize all the instructions and all, then things will get complicated and all. So therefore, we need to make sure that the common case should be faster. And the another one is that performance can be improved by using parallelism. So this is the obvious one. Like, yeah, as you have you can able to improve the performance by using the parallel, like for example, instead of single processor, if you have a multi-core processor, like where you have multiple cores are there, and also in that case, you can able to run the program effectively, and you can able to run the like you can achieve a better performance and all. Obviously, instead of single core system, if you have a quad core system and all, then obviously the performance will be improved, right? So therefore, that is a natural way of improving the performance by incorporating the parallelism in different aspects, as I mentioned earlier. Like we have a data level parallelism, instruction level parallelism, and by providing the memory and so on. And likewise, performance by using pipeline. This also we have mentioned, like in the previous example, as I mentioned, the instruction is not executed instantly. Like it has to undergo to the different stages. So one can able to cache on that. Like all those stages can be viewed as a sequential stages. So with that, instead of you cannot like you can exploit the concept of the pipelining. That means you cannot wait for take instruction. You don't wait for completion of that instruction till the next instruction to be fetched and all. So as long as this instruction is going on, so you just fetch the immediately next instruction and keep that in the pipe. So that suppose this instruction take some 5 or 6 stages to complete, and in the meantime you can fetch the other instructions also and put it in the pipeline, so that the instructions will be sequentially executed. So this is known to be concept of pipelining and all. And then sometimes the performance via prediction. It means that actually when you are executing the program or when you are doing certain thing, with some prediction, you just move forward. And sometimes the prediction may go wrong, but an average time, an average case where the prediction will go correct. And with that, you can able to get the better performance. Instead, actually, sometimes you may get the prediction may be wrong, but assuming that when you are mispredicting, at that time, the cost of misprediction should not be too high. So that way, if you can able to design a system and where you can go ahead with the prediction and thinking that, yeah, this can happen and all. Otherwise, for example, take in a program also. So if you want to make it some decision, so that the decision depends upon the execution of some procedure and all. And if you can able to predict something, you need not wait for that wait for that result and all. You can go ahead with the later part of the execution, and then if the prediction is correct, assuming that the later part whatever you are executing will be correct. Suppose the prediction is wrong, then you need to recover from that. That means you have to flush out the previous executions whatever you made, and then you have to take some other alternative path. But here in this case, you have to see that most of the times, or like in average sense, the prediction will be correct and all. And whenever the prediction is wrong, and you need to pay for penalty, but that penalty will be a reasonable one. And then the hierarchy of memories already we have discussed and all. So having the memory hierarchy, like fastest memory, which is a part of a processor itself or very close to the processor, or at different levels of if you organize the memories in a various hierarchy. If you look at here, it's like a three-layered one in the triangular fashion. The top one is the one where it offers very less capacity, but it is very faster and expensive. And then as you go down, the access time will be increased, and it offers very huge large volumes of the memory and all. So that way, if you maintain the memory in a various hierarchy, and assuming that always the processor has to fetch the data from the cache memory or from the memory which is close to in its vicinity and all. So that way the access time will be very less. Sometimes it may happen that when the processor want information from the cache memory or from the memory, faster memory, it may not be available here. At that time, you need to pay the penalty. That means you need to fetch the data from its lower level memory, and then so that time that will be those instances will cost more. Otherwise, the most of the times, the 90% of the times or 95% of the times, the data will be available. Data will be whatever the CPU asks the data that is available in the cache memory itself, so that the performance will be better or the fetching time will be better. And the another last one is the dependability or redundancy. So it means that actually dependability and redundancy, this is so in view of reliability, like when you're designing a system and all. So obviously all these systems are the physical systems and all, they bound to be going to be erroneous at some point of a time and all. So to take care of that, we can provide we can ensure the dependability via redundancy. It means that instead of in the place of multiple processors, for example, you have quad core system where you can keep the three processors for running the program, one processor as a standby kind of a thing, which used to monitor the status of the remaining processors and all. When some processor has gone down, has crashed something, then immediately the standby processor will take care of that one. Whatever the status of that one, it will take and then try to execute that. So this is the idea of dependability via redundancy and all. And this is very much required for the high-end servers and all, where it used to cater the information for the multiple users and all. So therefore, the redundancy is very important, very crucial for those high-end servers compared to the individual systems and all. So these are some basic ideas or the fundamentals where the computer architects will follow for designing the better systems and efficient systems and all. And the details and all, please go through the textbook and all. So I maybe missed some of them, but these are the various ones, and these are the various the symbols that are associated to these 8 fundamental ideas and all, like Moore's law and all these things and all. Some of them are more relevant to this one, right? The ideas. And so, for example, redundancy means you have a multi-wheel transport system, lorry and all, where you have the multiple wheels. So if one of the wheels has damaged, it still runs. It can still go on without affecting the whole system and all. So that was the idea. Likewise here also, like parallelism and all, multiple engines and all. So these are things. Yeah, the next one is what is the below your program. So this we have discussed to some extent in the last class and all. As I mentioned, you have application from a human point of view, like if you want to carry out certain tasks and all. And the application software is nothing but carried out by the like it's not the entire thing will be carried out by the human and all, at least at algorithmic level, then high level language and all. And there are different layers of application software also will may be there, that depending upon the complexity of the application and all, right? So this is the application software. That is nothing but whatever the task you want to perform. So related to that, the program, that is the program related to that in high level language is known to be the application software. It's basically from the name itself, it is specific to the application. It is specific to the application, right? So this is known to be application software. And then the system software, it is below the application software. You can see that here the concentric circles and all. So the center one, the lowest one is the hardware, which executes the actual programs and all. And the application software or application programs are there at higher layer and all. And these are not executed directly by the hardware, as I already mentioned and all. So therefore, you have some other software that will be there as an interface between these two. So this is known to be system software. And these system software are the mostly from the name itself. So this is the generic in nature. So this provides the interface between the actual user programs and its implementation by the system and all. So if you look at the system software here, it was just mentioned the two of the important system softwares. One is the compiler and other one is the operating system and all. The compiler's job and all, as we already mentioned, that translates the high level language code. Maybe if you write a C program or Java into the machine language code, that is the compiler's job and all. And the operating system will be like there is another system level software which performs a wide variety of tasks. It basically provides the interface. That means the hardware, as I mentioned, it performs a limited operations. Very few operations it will do it. But to perform a complicated applications by a system and all, the operating system will provide the interface where the user will not know about the internal details, but still he can able to run his programs very efficiently and without bothering about what is there, what is actual hardware that is supporting this particular execution and all. So that is carried out by the operating system. It's like a kind of the managerial thing where it used to manage the resources, the hardware resources and all, like handling the input output and managing the memory and storage and all, then scheduling the task. Because in case of multi-user system and all, we have a same system used by the multiple users and all. So in that case also, those multiple user applications also will be scheduled by the processor that is beneath the this hardware and all. So all these are the various tasks that will be carried out by the operating system and all. It's by itself is a it's a very big topic and all. So therefore we cover the details of this hardware, the concepts and the operating system in detail in the second part of this course. So we are not giving much. We are not taking more time related to operating system, because anyway we give enough time later part. And as I mentioned, that operating system is nothing but, you can see compiler means it is a very clear designated task. As I mentioned, all application programs will be translated to machine code. That's the job of the compiler, more or less. And in addition to that, there are other slightly other application, other tasks also it will do that in addition to that. But the operating system will do a very broader level interface. It will do the very broad, so several system level services it will offer to the application programs and all, as I mentioned, because it tries to manage the hardware, because hardware is just devices and all. It just effectively manage the hardware so that the system efficiency will be improved, so that user will get a satisfaction when you're running the programs. So all these things will be carried out with the help of the operating system and all. And finally, the hardware that is below that, but the lowermost layer is the hardware, which consists of processor, memory, I/O controllers, I/O devices, and so on. So these are the various modules, or we can say that various aspects that were there below the code. And anyway, this is the one just symbolic the representation of this one, diagrammatic representation of the translation of high-level language code to the machine code and all. As I already mentioned that, so the high-level language is nothing but hello. Hello.
Yes, sir.
Yes, you're audible.
Uh, 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 so can you see the slide now? Is the slide is visible? Hello?
Yes, sir.
Yes, sir.
Okay. Yeah,
Yes.
somehow for me, yeah, I think immediately actually I got a different screen. That's why, yeah, right. So the slide is visible, no, right? Okay, yeah, okay. So yeah, you can see this particular slide. This is already we have discussed, and you can see that the high-level language. Yeah, above that we have algorithm, at a very sequence of steps and all. And this is high-level language where the people who are aware of the high-level language, they can able to code the algorithm into the corresponding language. And this will be easier. The level of abstraction is close to the problem domain because these high-level languages are close to the natural language and most of our natural languages. So therefore, the humans can able to code effectively the algorithm using a high-level language and all, right? And so with that, it provides the better productivity, and the productivity means they can able to very efficiently they can able to code with high-level language, and with the portability also. Using this high-level language, you can able to run this program, or can the same program can be run on any system, provided you have a appropriate compiler will be there. So this is the high level language, and then this high level language will be translated into the assembly language using the compiler. Here assembly language means there is one more term that was added over here. So the assembly language means this is the symbolic representation of the instructions, because this is because at the beginning, maybe in 70s or 60s and all, at that time these high level languages are not that popular, or not exist. Not many high level languages are exist at that time, and even the computers also used for limited use and all. So for that, at that time they use the only assembly language for coding. They don't use the they don't have the luxury of this high level language, and they use only assembly language because they know that what the processor will do, what the hardware will do, what are the basic functions the hardware will do. By knowing that, they try to represent whatever the task is there. They directly code the task, code the application using this assembly language, using the instructions where the hardware will understand. But hardware actually understands only the binary sequence, only the binary numbers, bit sequence and all. So, but it's difficult to directly code the bit sequence. So that is the reason that this assembly code has evolved. The assembly code is nothing but it's a symbolic representation of the instructions where the hardware can implement directly. So like this add, load the word, store the word, jump register. Likewise, these are the various instructions, and where these are actually the machine understands only these binary sequence. But humans will be very difficult to code in the binary sequence. So therefore, this intermediate one, the symbolic representation of what is that actually? Hello, hello, hello,
Yes,
students.
yes.
Yes, sir. You are audible now.
Yes.
Hello, hello.
Yes, sir. You are audible.
Yeah. Hello. Oh, okay. Yeah, I think there is some network issue, like bad network quality. So because of that, okay. Yeah. Let me. Hello? Yeah, students?
Yes, sir. Yes, sir.
Yeah, I
You are
think it's some link failure. That's the reason I'm not able to connect. So now, yeah. Hello? Hello, Sudhakar?
yes, sir. You are audible.
Yeah, I think there is a link failure the
Yes, sir.
Wi-Fi failure
Yes.
from my side. So now it has been connected and all. So anyway, so now you have almost like 8:55. So you had to join the other classes also. So we'll stop here at this point, and again we'll meet on Monday. But actually we had to cover a lot actually. So it's slow. Anyway, we'll start. We'll continue in the Monday. Okay, and those whoever want to take this course and also tell your friends or whoever qualified, as I mentioned, like so by today is the last date. They can place the request through ERP and all, so that I will finalize today. Okay, and afterwards there is no more request will be entertained. And today we'll see that today mostly whatever the requests are there, I will try to honor that. Okay, is it clear? Hello, hello, students.
Yes, sir.
Yes, sir.
Yeah, yeah, Aditya, are you there?
Please once again repeat the criteria.
Hello. No, no. What I'm saying is that you just tell that today, whatever the requests by today, whatever there, so that those things I will try to honor, and later on I will just close the like approving the request and all. I will try to freeze the course, like course for the other people who want to take approval, who needs the approval through the ERP and all. But anyway, the students, those who can able to directly join without my approval, then they can do that. They are mostly they have done, like most of them were joined already. I can see that from the electrical department, there are about 110 students. How many, what is the strength of electrical branch? Any idea? Like there are two parts, electrical and instrumentation. The instrumentation, I saw that the number will be close to 30 right now. And the total will be 110. I saw that. Is the strength is close to that? Or
Yes, sir.
huh? Is it close?
Electrical is 110, sir.
110. Okay, good. Okay, good. Yeah, right. Then it means almost like all of you have been registered and all. Okay, fine. Yeah. So Monday we'll continue. Monday class is at 12 o'clock and we'll continue. In the meantime, I may interact with you with this one with the email if require anything, and I will upload the slides today. Okay.
Sir, for all the
Uh,
other
uh,
departments, sir, EC
yeah.
department, get approved directly, or do we have to do something else?
No, no,
Because
I,
I've
no,
got
no, no, no. What I will do is that today I will approve in the afternoon, and then you need to check with your faculty advisor to sign it. Then only your names will be reflected in my roll list and all. Okay. Hello. Yeah, you can see that the moment when I approve, then maybe in your ERP you can see that the faculty has approved or some status you can able to see, and then you can check with your faculty advisor. Your faculty advisor has to approve your registration. Then it can be I can see the your names in my roll list and all. So that you please ensure that at the earliest. I told you today I will approve most of the cases and all. Okay. Yeah, and before that, those who really want to do that, so please be there, stay there. Otherwise, you can just voluntarily can withdraw. That's better and all, because after in the middle, if you are not cope up with the course and all, it will be difficult. As I told you, the course is very wide and it requires the background, certain background. So if you have that background and all, it's fine. And otherwise, no, in the middle, if you lost the hope and all, it will be difficult. So and that too is an online course and all. Getting the help from the friends also will be not that as in the case of physical situation and all. So please think all those things, and those who want to withdraw voluntarily, so please do that. Don't take the risks in between and all. Right? Okay. Yeah. So any other questions? Okay. Yeah.
Sir,
Shall we tell me? Yeah, please.
sir, could you please repeat the criteria for approval?
Yeah, that's what I told. No, right. The criteria will be like as long as you have that. No, and another thing, what I'm not checking one by one and all, like whether you have taken that course and this course and all, but it voluntarily or like from your side, you had to be sincerely. You had to whether that if you had taken that course. I told you, know, this is a prerequisite. If you look at the CSE minor, criteria. So in that, this course will be there. Under this course, it will be mentioned that the prerequisite from 2A or 2B, like that. 2A, 2B means that one. Like under the 2, there are 2 courses will be there: switching circuits and digital electronics. So that is the criteria. So therefore, you have to know that, and so please that if you have that criteria, you be there. Otherwise, it will be very difficult, and it's hard to follow that, right? So therefore, if you don't have that prerequisite, so you please voluntarily withdraw, because I cannot check that for 100 people that you have taken that preceding in the previous semesters you have that course or not. So I assume that the list, whatever that the list of requests from the ERP, I assume that your requests are sincere and all. That means that so all of you have taken the prerequisite, sufficient prerequisite to handle this course and all. And mostly, then I will go by that. Right now, the number is just little exceeding the previous year and all. So therefore, I will try to honor most of the requests and all. But be yourself will be like very genuine and sincere and all in view of these the prerequisites and all. So otherwise, I will accept all the cases and all whatever is there listed there and all. Okay, is it clear? Hello?
Yes, sir. Yes, sir.
Sir,
Oh
actually,
yeah, fine. Okay.
okay, I've received a mail that says the course has been rejected from you, like when you send the Teams link that. So is it like if it is if you cancel, will it still be there the approval for
No,
like the subject?
no, I am not getting that. If you withdraw, it is there still there in the approval. That's what you are saying, right?
No, sir. Like if initially you've sent a mail that said I've rejected the subject for you, and
No,
then like with that.
I have not. So far, I see that I have not approved any cases. Just observing the total list and all. So it was there. So I have not rejected. But in the initial mail, what I had told you is that actually I'll try to limit the number to 200 and all. That's what I told you, right? So, but now I'm saying that there are very few, like anyway, last year also we had up to 230 or something. And now the number actually, because after that there will be some withdrawals will be there. So by keeping that in mind, right now whoever is applied for all of them, and their CGPA is also decent, most of them except very few. And so therefore I will try to approve all the requests and all. But before that, what I'm saying is that you voluntarily see that whether you can really fit to this course or not. So for that, actually, what I'm saying is that you should have the prerequisite is required, or whatever the prerequisite, whatever I mentioned. So if you, yeah, so that's what I'm saying. So therefore, I will try to accept the request from the ERP straight away in the afternoon. I will wait till afternoon and then I will like approve most of the cases and all. Hmm? So, but you yourself will see that like whether you have taken that prerequisite or if you have not taken the prerequisite, so please please you yourself can withdraw from that. You can have always you can do that so that you will be in a safer side. Otherwise, no, at a later point of a time, it will be hard to follow the classes or sometimes in the lecture concepts also. That's what I'm saying. Hmm? Okay, yeah. I hope it's clear more or less, right? The admission process, evaluation process, everything and all. Okay. Yeah. Thank you then. Hmm? Yeah. Okay, fine. Shall we leave? Hello? Yeah. Okay. Sudhakar?
Yes, sir. Yes, sir.
Yeah,
Fine,
yeah,
sir.
right. So then we'll leave. So if anybody asks, just you may respond and all. I'm leaving. Okay.
Yes, sir.
I
I will
have
ask.
some other work
Yes,
also.
sir. Okay.
Okay, thank you. Yeah, I think I don't know whether. Oh, it's still recording. Okay. Yeah,